Hi guys, welcome to Algebra 2. We're going to go ahead and get started in this unit with relations and functions. A relation is a relationship between a set of values, and most of the time when we're writing relations you're going to be using ordered pairs, but you could also have it in the form of a graph, or you could have a set of data in a table. You could also maybe have it on a map where it's two circles or ovals that have a list of numbers that are paired with each other. For example, it might look like this, with arrows connecting the things that go together. Okay, so that's an example of a relation. A function is a kind of relation, it's a more specific kind of a relation, where all the inputs only go to one output. Okay, so everything on the one side can only go to one thing on the right side. Right, so we're going to go through some examples in the ordered pair form first, just showing you what those look like. The first relation we have here is a set of ordered pairs. I've got 2, 4, 6, 4, 0, 3, and 4, 1. So in order to determine is it a function, we have to look at all of the numbers and see if every x value goes to only one y value. So here we have a 2 that goes to the 4. We don't have any other 2's, so that's a good thing. We have a 6 that goes to 4. That's okay because there's no other 6's. We have a 0 that goes to 3 and a 4 that goes to 1. So notice there are no repeating x's, so automatically that would mean that yes, it is a function. And I can put here no repeat x's. Okay? Now, the domain and the range, these are going to be very important the entire semester. The domain is all of the x values. So if I want to list those x values, I would normally put them in order, but it doesn't really matter. So the lowest one is 0, 2, 4, and 6. So that is my domain. The range would be all of the y values. And so my y values would be 1, 3, 4, and 4. And you can write repeats more than once, but you don't have to. So you could just write 1, 3, 4, and that would be perfectly acceptable. All right? So there's how we tell if it's a function, and then we just list the domain and range. In this example, same thing. We're going to determine if it's a function. 3, -1, 2, -2, 0, 2, and 2, 1. So if you look in this list, the problem is we have two x's that are the same. So 2 goes to -2, but it also goes to +1, and that's a problem because you can't have an x go to two different y's. And that means that this would not be a function because it's a repeated x value. So you can have repeated y's, but you can't have repeated x's. Very important. And then we can still list the domain. So you list all your x values, you can write repeats if you would like, and then all your y values, -1, -2, 2, and 1. And then you'd be done. The next thing is the vertical line test. So these are when you're looking at the graph form of functions or relations. The vertical line test is used if you are trying to determine if a graph is a function, okay? Because not all graphs are considered functions. And all you have to do on this is take a graph and then use a vertical line. I'm just going to draw a green dotted line. And if you drag that line across the graph, it will pass if it only hits the graph one time everywhere. So notice my vertical line hits my graph once here. But if I drag my line somewhere else, it still only hits once here. So the line only ever hits the graph one time at a time. So there's my line. That would mean that this passes. So it is a function. It passes the vertical line test. Same with this line over here. If I drag my vertical line anywhere on that graph, I only ever hit one point at a time. So this would also be a function. Now, an example where it wouldn't would be if I have a graph like this. Maybe here. So notice that when I draw my vertical line, I hit two places at once, there and there. That means it automatically fails the vertical line test, so this is not a function. All right, so very quick and easy. You don't even have to draw the lines. You could just use your pencil and go straight across the graph. Most of you might even just visually be able to tell right away. Just check that, then write function or not a function. That's it. The last part we're going to cover in this video would be the domain and range of graphs, and it's a little different than the domain and range from a set of points. In a domain and range of graphs, you have to look at all of the potential x's and all of the potential y's that would fit on the particular function that's plotted. And that could be a very, very large range of numbers. And you don't want to list all the positive numbers and all the negative numbers that could possibly be included. So instead, what we do is we use some shorter notation to include a large set of numbers. And I'll show you what that looks like. We're going to go ahead and start with an easier one, which is this example here on the left. We've got a straight line that's graphed. So when we talk about the domain, I'll write this down, you want to think about all of the x's that this line would graph. Okay, so when I go to the right, notice my graph, the arrow says it's going to keep going up and to the right. It's going to keep going this direction. Okay, so further and further over to the right. The left side also has an arrow, so that means it's going to keep going further down, but also as it goes down, it's going to keep going further and further to the left. So I'm going to be going to the right and to the left forever, both directions. And what that means is that I could have any number from negative infinity to positive infinity that would work on this graph. And so the way we write that is with parentheses, negative infinity to positive infinity. It looks like an ordered pair, but you're saying I can go from one number to the other. And the reason we use parentheses is because you can't actually hit infinity. So they use the parentheses to show you that you can't actually write that as a number. Okay, so negative infinity to positive infinity, or you can write it as all real numbers. That means any numbers that are real, we would count. Okay, the range is the same concept, but this time instead of looking at the x's, so left to right, we're looking at up and down because y's go up and down. So for my y's, remember the arrow tells me I'm going to keep going up. It's going to go up forever, and this arrow tells me I'm going to keep going down forever. So again, because it goes up and down forever, it'll be the same thing, negative infinity to positive infinity, or you could write it as all real numbers. Either one is fine. If you're going to go on to pre-calc or anything past that, you'll definitely see this notation in parentheses that's called set notation. You'll see that a lot more, especially in the textbook. Okay, so those are your domain and range for the lines. In this example number 2, it's a little different. We still have arrows, okay, but then those are going to tell us something, but we also have this graph that stops at this low point here, so that's going to be important. So let's start with our domain first. Remember, domain is the x, which means the left and the right side. So as I look at my graph, I'm going to go to the right, and it's going to keep going. It doesn't stop. So same with the left. I start at my graph, I keep going to the left. My arrow says it should keep going. What that means is my domain, just like the first example, it would be negative infinity to positive infinity. Right? My range, however, is a little different because in the first example it went down and up forever, but this one, when I follow my graph, notice that it gets down to, let's see, that's -5, and then it starts to go back up again. So it goes up forever. Both these arrows say it goes up here and up here. Okay? But the lowest it goes is -5. So what that means is my lowest value is going to be -5. We always write the lowest one on the left. But my highest value, both ways, is going to be positive infinity. Now notice I wrote a square bracket here. The square bracket means it actually hits -5, so it's included. Think of it like a closed circle. Okay, if it's a closed circle, you use a square bracket. If it's an open circle or infinity, you use the parenthesis. So this says that the lowest my graph goes is -5, and it goes all the way up to positive infinity, and it hits any y in between. Okay, let's try this next example, and then this will be the last one. So here, let's start with the domain. Remember, we're looking from left to right. So if I look at this graph, what's the furthest x value to the left? Well, it happens to be on the x-axis. It doesn't have to be, okay? But my furthest it goes over there is -3. And the furthest to the right, anywhere that I go for my x's, is +3. Okay, now it won't always hit the x-axis, so keep that in mind, but it just happened to on this one. So furthest left is -3, furthest right is +3, and it hits every x value in between. And then we'll do the range. So remember, that's the lowest and highest y value. And so the lowest my graph goes is at -4. And the highest my graph goes is all the way up to +3. So I'll write +3, and then I'm done. So notice that here we don't have any infinities because this graph didn't go on forever in any direction. It had highs and lows, and then it had numbers to the left and right that it stopped at. Okay, so this is more restricted than the first two examples that we had. If you have any questions about how to write the domain and range or where I'm getting the numbers, please don't hesitate to ask, because I know this can be a little tricky, but hopefully the practice will help you get started and you should be good to go. Thanks for listening.